Welcome to our session of Physics Practical. Welcome for this time to learn about the experiment number 7. We have a series of this experiment. Now we are in experiment number 7, apart from the experiment number 1 up to number 6. Experiment number 7, we have some questions. That is a new experiment. You are required to determine the resistivity of the wire provided within this experiment. We are going to consider our circuit, experimental circuit, and this circuit guided us or guided you to connect a circuit by using apparatus to perform procedures in order to solve the questions asked within this experiment number 7. Our circuit comprises our EMF of a battery, our standard resistor which is 2 ohm. We have resistivity wire. This is the length of resistivity wire. It is connected parallel within a switch or within a key, plugged key. And we have ammeter to read the current flowing through a circuit. That is our circuit. And you see that a circuit, to give us a principle we are going to use on derivation of the nature of the graph and how to solve the resistivity of this wire. A procedure to perform this experiment according to our circuit: when you perform, take readings of a current by varying the length of the wire from 20 up to 100 centimeter. You are going to connect 20, you read the current, 40 you read the current, 60 you read the current, 80 and up to 100 centimeter you read the value of current, and you record your readers, the current and the length of your resistivity wire. And when you perform this procedure, you have to leave the key open throughout the experiment. Don't close the switch. Even if you are not closing the switch, the current is passing through this resistance 1 and the resistance 2 of the resistivity wire. So your circuit, it has 2 resistors, resistor 1 and the resistor 2 of the resistivity wire. That you have to note. Questions which can appear from this experiment: plot a graph of 1 over I against the length of W. Calculate the slope of the graph, and then using the EMF of the battery, find the resistivity of the wire W, and then find the internal resistance of a battery. Those are questions you have to answer by calculating or by solving after recording the data of the results. This question number C, using the EMF of the battery. Which is EMF? How you are going to determine or to obtain the EMF of a battery? Before performing the N experiment, you have to record the voltage of the cell, the EMF of the cell, by using the voltmeter. You have to record before and not after, because when you record after, it means your battery have been used or the voltage have been used, so cannot be exactly. So you have to measure before using this cell or battery in order to get the exactly EMF of that battery, and in order to get the accurate the resistivity of that wire you have been provided. Let's proceed with the theory of this experiment. The theory of the experiment: we have this circuit. Remember that we have 2 resistors. The first resistor is 2 ohm, and the second resistor you have resistivity wire. So our general equation would be EMF is equal to current resistance plus resistance of wire and the internal resistor of a battery, this one. You are required to plot the graph of 1 over I against the length of wire. So you have to derive this equation in order to get 1 over I as y-axis and the length as x-axis. From this equation, this one, from this equation, you have to add the r here. I is equal to E over R plus RW of wire and the internal resistance. In order to get 1 over I, you have to make reciprocal of this equation. So it will be 1 over I is equal to R over E plus R over W over E plus R over E. That is our reciprocal of this equation. Then, in order to get the length of L or W from this equation, you have to apply resistivity formula. Resistivity of wire is equal to area resistance times resistance over length. So we are going to substitute. Apart from this RW, we are going to put the resistance or resistivity times length over area to this formula, and the area is equal to pi d square over 4, and the d square, this is diameter square of wire. You record your diameter by using micrometer scale gauge. Then we proceed with the equation. So resistance of wire will be resistivity times 4 times L over pi d square. So we are going to put this one into this equation. Will be this one. So 1 over R is equal to R over E. 1 over I is equal to R over E plus, this is resistance of W. We use the resistivity formula. It means it will be resistivity times 4 times LW over pi d square over EMF plus R over EMF. That is our equation from here, this one, and we reach in this equation. So you see how is it derived. 1 over I is equal to resistivity times 4 times LW pi d square over E. It means when you divide with this one, will be E will be times 1 over E. So EMF will be down of this value plus R over E plus R internal resistance over EMF. General equation of this would be 1 over I is equal to this equation times L plus R, which is internal resistance over EMF. This one have been joined. This equation have been joined. You see, is reaching here. Then you get with the y is equal to mx. Y is equal to 1 over I, m which is the slope with this equation, and the x is L, and the c is equal to r plus r. That is our equation. Nature of a graph is a straight line passing through y positive and a negative x axis with the positive slope. You see, that is the nature of a graph. 1 over I against the L W in centimeter. Y-axis is equal to 1 over I. X-axis is equal to LW. Slope is equal to pi 4 is equal to resistivity times 4 over pi d square times EMF, and the y-intercept is equal to R plus R over E. Therefore, to find the internal resistance of R of a battery, you have to consider this graph. Internal distance obtained from y-intercept. Y-intercept is here. You see that is mouse point. You read this, the value of your graph, and you are going to substitute within this equation. R is the standard resistor you have been provided, which is 2 ohm. EMF measured before experiment, and the standard resistor is 2 ohm. So in order to get the value of internal resistance is equal to EMF times y-intercept over 2 resistor or 2 ohm. That is the value of internal resistance you can be obtained from that way or that equations. And to find the resistivity, slope is equal to resistivity of y obtained from slope. Slope is equal to resistivity times 4 times over pi d square times EMF measured before experiment. Resistivity of wire obtained from by using this formula. So after calculating the slope, you have to equate this, and then you'll be able to solve resistivity of wire. That is our experiment number 7. I think you have understand more about this lesson, experiment number 7, physics practical. Thank you for learning with me. Subscribe our channel, like, give us a comment, give us a feedback, and the next session we will proceed with the experiment number 8.